At first light, the tower looks less like a mountain than a severed thing. Its walls rise in straight vertical bands, ribbed and dark, as if something fibrous once stood here and was cut clean through, then left to harden in silence. Around it, the ground spreads outward in a low skirt of broken stone and pine, the way sawdust spreads around a stump. People have photographed places like this for more than a century. They file them under geology, tourism, natural wonder. But the first impression never quite goes away. Why does a familiar landscape sometimes look like evidence from a world we no longer know how to describe? The accepted explanation is clear enough. These formations, we are told, are volcanic necks, igneous intrusions, resistant cores left standing after the softer surrounding rock eroded away. And the columns are cooling fractures. The flat tops of mesas are sedimentary layers protected by harder caprock. The rings, aprons, benches and debris fields around them are ordinary products of weathering, runoff, uplift and time. In that account there is no mystery, only duration. Millions of years provide the sculptor. Erosion does the rest. And to be fair, that explanation is not invented to silence questions. It is built on real processes, real measurements, real fieldwork, and a geological framework that explains an enormous amount of the visible Earth. But there are landscapes that resist that comfort. Some buttes do not merely resemble stumps in a poetic sense. They resemble them in proportion, in texture, in the way the surrounding terrain seems to flare outward, always in the way isolated towers stand where a larger body appears to have been removed. Some ridgelines look less like random collapse than grain. Some circular plateaus look less like uplift than cross-sections. And once that possibility enters the frame, the official account begins to feel complete only because it is broad enough to absorb almost anything. A volcanic remnant can explain a pillar. Erosion can explain a flat top. Sedimentation can explain a band. But explanation is not the same as resolution. A category can end a conversation long before it answers the deeper pattern. The hidden theory is simple, and for that reason it is usually dismissed before it is examined. What if some of the world's strangest towers, mesas, and isolated rock masses are not merely rock formations that happen to look biological, but the mineralized remains, casts, or root structures of an earlier arboreal world on a scale far beyond anything in the modern biosphere? Not every mountain, not every butte, not every columnar cliff, but some. Enough to matter, enough to force a question. The claim is not that every geologist is lying or that every map is wrong. The claim is narrower and therefore more difficult. It is that a few categories may have hardened too early, and that once the land was labelled, the land stopped being read. Start with the physical geometry. A stump is not just a cylinder. It has taper, flare, radial stress, layered interior organisation, and a relationship to the ground around it. When you compare ordinary tree stumps across species, ages and environments, you find that the cut surface, the sidewall texture, and the transitional base all tell a linked structural story. Some of the most discussed mountain scale anomalies exhibit a similar linked story. There is the vertical exterior broken into parallel bands. There is the abrupt transition at the base, where the mass seems to widen into an apron or root-like spread. There is the relative isolation from surrounding topography, as though the central form is not merely one eroded point on a continuous ridge, but the surviving remainder of a distinct body. Scale does not erase geometry, it magnifies it. And if the geometry repeats where standard processes predict more variation, the repetition becomes evidence of form, not just accident. The strongest mainstream rebuttal comes quickly, and it deserves to be heard clearly. Columnar jointing is real. Basalt and other igneous materials do fracture into strikingly regular vertical columns when they cool. Geology is full of structures that appear designed, patterned, even biological, without being biological at all. Crystal growth, cooling stress, sedimentary layering, and differential erosion produce shapes that can mislead the eye. That is true. It explains a great deal. It may even explain the majority of cases. But it does not explain why certain formations inspire the same comparison independently, across generations, across cultures, and often before the public learnt the geological language later assigned to them. Nor does it fully explain why some of these structures possess contextual features that seem oddly organic in combination: the flared base, the abrupt severed top, the associated radial ridges, the absence of obvious volcanic architecture nearby, or the surrounding terrain that looks less like a lava province than a field of removal. Then there are the maps, not the dramatic maps displayed in documentaries, but the boring ones. Survey maps, relief maps, mining maps, contour sheets, drainage maps. These records flatten romance. That is what makes them useful. Over and over, certain isolated landforms show the same relationship to their surroundings. The central mass rises steeply. Around it lie concentric zones of debris or stepped benches. Beyond that appear radiating ridges and channels, some of them so evenly distributed that they look less like random drainage and more like a structural pattern imposed before erosion began. In ordinary geology, such arrangements can result from joints, bedding, runoff, and slope failure. But when the terrain resembles a root flare at one scale and a watershed at another, interpretation becomes unstable. The pattern repeats. That does not prove arboreal origin. It proves that the land is carrying more than one readable language at once. Old photographs deepen the unease. Early panoramic images of the American West, Central Asia, Southern Africa, and parts of Australia often show isolated masses rising from plains with a cleanliness that later images sometimes obscure. Before paved roads, before visitor centres, before interpretive signs, many of these structures were photographed as raw anomalies. Their surfaces appear less softened, their bases look broader, the surrounding land looks more stripped. Even more revealing is the language used around them. Surveyors, settlers, and local communities repeatedly reach for biological metaphors before technical geology standardized the view. They called things towers, trunks, chimneys, stumps, roots, petrified forests, and giant wood. That does not make them right. Folk description can be naive, but first impressions matter when they persist. People often describe what a thing most obviously is before institutions tell them what it ought to be. What matters even more is the scale problem. Modern biology gives us categories for trees, forests, root systems, lignin, cellulose, silica replacement, and petrification. Modern geology gives us categories for intrusions, plugs, dikes, joints, uplift, and erosion. But those categories were built around the size ranges we know. Once an object moves far beyond familiar biological scale, well, it tends to migrate conceptually into geology, whether or not that migration is justified. A tree 10 stories high is still a tree. A tree a mile high, if such a thing had once existed, would be reclassified in the human mind before it was reclassified in the textbook. The problem is not necessarily deception, it is category failure. When something exceeds the expected dimensions of life, we stop asking biological questions. What changed was the explanation. Consider fossilization itself. The Earth preserves organic forms in ways that are often astonishingly incomplete and astonishingly selective. Wood can be replaced cell by cell with silica and still retain microscopic structure. Bone can mineralize. Shell beds can turn to stone. Entire forests can be buried, compressed, altered, and reappearing only in fragments, casts, carbon seams, or chemically transformed remnants. The mainstream record already accepts that the planet once supported vegetation and organisms in distributions, densities, and atmospheric contexts unlike those of today. Coal seams testify to botanical abundance on a scale modern ecosystems do not replicate. Petrified forests testify that wood can cross into stone without losing its identity entirely. The question is not whether biology can become geology. It can. The question is whether some geologies were biological before they were geological, and whether scale has made that transition effectively invisible to us. At this point, the obvious objection returns. If mountains were tree stumps, where are the rings, the bark, the branches, the cellular tissue, the consistent fossil signatures? The objection is fair. And if the theory is to be entertained at all, it must survive ordinary skepticism. And there are at least 3 reasons the absence of obvious tree-like detail does not end the inquiry. First, extreme scale would distort expectations. Grain at one scale becomes ridging at another. Rings would not necessarily preserve as clean circles across weathered cross-sections exposed to tectonics, hydrothermal alteration, pressure, and time. Second, preservation is selective. Most structures would be destroyed, not saved. What remains may be casts, cores, mineral replacements, or stripped structural remnants rather than complete petrified trunks. Third, many candidate formations are interpreted before they are tested against that possibility. Once a body is mapped as igneous, no one looks for arboreal microstructure. The record is still there. Actually, the question is whether anyone asked it the right way. Widen the scale and the theory becomes more difficult to laugh off. Around the world there are landscapes that seem to belong to the same family even when standard geology assigns them different origins. Flat-topped mesas with abrupt perimeter cliffs, isolated columns with fluted sides, circular uplifts with depressed centers, radiating ridge systems that resemble exposed root architecture, vast fields of broken stone that look as though a larger structure shattered and was carried off. In one place the explanation is volcano, in another erosion, in another sedimentary capping, in another tectonic uplift. Each explanation may be locally correct, but when the visual grammar repeats across separate categories, the categories themselves deserve scrutiny. The pattern does not disappear simply because the labels change. There is also the issue of missing infrastructure. A classic volcanic narrative usually comes with companions, feeder systems, associated deposits, volcanic fields, ash signatures, intrusive relationships that fit a larger magmatic story. Often those companions do exist, but in some cases the surrounding context feels strangely underbuilt for the confidence of the explanation. The central formation is named with precision, while the missing system around it is reconstructed from inference. Erosion removed it. Burial obscured it. Later processes erased it. Again, this may be true. Geology routinely works from surviving traces, but the same courtesy is rarely extended to biological alternatives. And if a volcanic system can be accepted from partial evidence because most of it is gone, then a biological megastructure should not be rejected merely because most of it is gone. Evidence should be weighed symmetrically. Otherwise, certainty becomes a habit, not a conclusion. And this is where institutional behavior matters, not conspiracy, not men in dark rooms rewriting maps, something much more ordinary and much more powerful. Classification, funding, professional inheritance, and the inertia of accepted models. Once a formation enters the literature under a geological label, every later paper begins from that label. Grants, field notes, museum plaques, park signage, educational material, and public memory all inherit the same premise. A young researcher does not build a career by proposing that a famous mountain might be miscategorized as non-biological. Not because the idea is dangerous, but because it sounds unserious inside the current framework. Bureaucracy does what secrecy does without an intent. It narrows what can be asked. A theory can disappear without ever being suppressed. It can simply become unthinkable in professional language. There is another clue hidden in plain sight: the human tendency to normalize landscapes once they are named. A place called a butte becomes a butte forever. A mesa becomes a mesa. A volcanic plug becomes a volcanic plug. The label is treated as neutral, but it quietly tells the eye what not to see. This matters because resemblance is usually dismissed as superficial, as though shape were the least important thing about a structure. But in paleontology, morphology is evidence. In botany, morphology is evidence. In anatomy, morphology is evidence. Only in certain geological disputes is morphology treated as suspicious, the moment it suggests life where stone was expected. Of course, resemblance alone is not enough, but resemblance plus repeated context, plus preservation pathways, plus early descriptive language, plus categorical inertia is no longer nothing. it becomes a dossier. Even the emotional history of these places points in the same direction. People do not respond to them as they respond to ordinary cliffs. They respond with a specific kind of recognition. The object feels cut, it feels interrupted, it feels left over. The top appears pavered rather than merely weathered. The base appears anchored rather than merely deposited. I found the surrounding land often looks scraped back, as if a larger body once occupied the space that is now empty. This is not science by intuition, and intuition can mislead. But persistent human recognition has often preceded formal explanation rather than followed it. Sailors knew coastlines before cartography. Miners recognized ore patterns before chemistry explained them. Farmers read soil before laboratories classified it. Sometimes the eye notices a structure long before the vocabulary arrives. None of this proves that giant trees once ruled the earth in the literal mythic sense. The theory remains speculative. It risks overreading form, compressing different processes into one narrative and mistaking visual analogy for origin. That warning must remain in view. Some mountains are plainly mountains. Some columns are plainly columnar rock. Some mesas are exactly what geology says they are. The serious version of this theory does not need all cases. It only needs a few misfit formations, a few preserved anomalies, a few places where the conventional account is adequate on paper, but curiously thin in physical intuition. Hidden history often survives not in dramatic revelations, but in residue, in the detail that never quite settled, in the explanation that works except for the shape in front of you. What remains then is not a solved alternative history, but a reframing. Perhaps the ancient Earth supported forms of life, growth, and environmental conditions that later ages reduced to mineral records so thoroughly that we now sort their remains into the wrong shelf. Perhaps some landscapes we call geological are biological in deep disguise. Or perhaps the theory is wrong in its conclusion but right in its accusation. That the land still contains forms we have not interpreted with enough imagination or enough discipline. Those two failures often arrive together. One side wants fantasy, the other wants closure. The harder task is to stay with the anomaly long enough to let it become evidence or to let it collapse honestly under scrutiny. The stone remembers. Not in legends, but in surfaces, proportions, and absences. In the way certain towers rise like cut trunks. In the way certain plateaus spread like sawn crowns. In the way some mountains look less built than interrupted. The official explanation may be correct. In many cases, it almost certainly is. But official explanations also have a habit of becoming complete long before they become final. And if even one of these formations is not what we have been told it is, then the implication is larger than a mistaken label on a map. It means part of Earth's visible past has been standing in front of us all along, mistaken for stone, because we no longer believe life could ever have been that large. So the unsettling possibility is not simply that giant trees existed and that their stumps are now mountains. It is that the world may preserve memories too large for our categories, and that once those categories hardened, the evidence became scenery. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.